So 6.3, day 3, we're going to take a look at inverse properties and finding inverse functions. Now remember the logarithmic form, log base b of y equals x, and b to the x equals y. So we're going to use that in order to help us find inverses. So using inverse properties, by the definition of a logarithm, it follows that logarithmic functions, g of x equals log base b of x, is the inverse of the exponential function f of x equals b to the x. And so if you have log base b of b to the x, that just equals x. So notice this cancels out. Then if you do f of g of x, b raised to the log base b of x, that cancels out. And so we end up just getting x. In other words, exponential functions and log functions undo each other. And so we're going to use these properties. So if you see the log with the same base and of that base, it's going to cancel out. If you have the base b and then it's raised to the log of base b, then we can cancel that out as well and just focus on the exponent. So let's try this example here. Simplify 10 log of 4. And so do we need to rewrite this one? In this case, we don't, and we'll see an example of when we do. So if there's nothing here, what do we remember is that base? Well, that is log base 10. And so looking at the property we have up here is that if we have the base and it's the same here and here, then we can just cancel this out. The answer is just 4. So that is the answer. For the second one, let's try this. Log base 5 of 25 of x. Now, notice that 5 and 25 are closely related. So in this case, we do need to rewrite it. We want this 25 to be a 5 instead. How can we make it look like a 5? So remember, 25, we can make that be a 5 squared, right? 25 is the same as 5 squared. And so that helps us because then that's the same base there. So log base 5, and we're going to write 25. The 25, we're going to rewrite that as 5 squared. And then that x still exists, so x. And so what's going to happen is that's going to multiply. Now notice, because we rewrote that, log base 5 of 5 can now go away, and now all we're left with is the exponent, and so the answer is 2x. So try out these two examples here. Simplify 6 raised to the log base 6 of 27, and number 2, log base 7 of 343 raised to the negative 3x. Now, if you tried it out, so the 6 log base 6 cancels out, and so the answer is 27. Now, with 343, 7 raised to the third power is 343. So what we're going to do, what you can do, is you rewrite the 343 as 7 to the third power, and now it cancels out. And so you were left with the 3 times negative 3x, and that answer is negative 9x. So now let's find inverse functions. So there's going to be two ways I'm going to show you how to do this, and it's up to you as to what method you would like. So method 1. So we're going to find inverse of f of x equals 6 to the x. So remember what we do is the first thing you do is rewrite f of x as y. Y equals 6 to the x. Then you switch the x and the y. So x equals 6 raised to the y. And then we're going to write it in new form. So if this is an exponential, we're going to rewrite it in log and then so forth. So remember thinking about rewriting an exponential as a log. So if the base is 6 here, we can rewrite it as log base 6, and then it equals the exponent, and then what's left over is the x, and that goes in here. So therefore, this is g of x equals log base 6 of x. And so that is rewritten. Okay, and that is done. So now another way to think about this is that if we get to this point here, so method 2, another way to think about this is that if we have x equals 6y, and so what we want is we want that y to not be in the exponent position. And so another way to think about it is how can we get the 6 to go away? Now looking at the properties that we had over here, remember what it looked like here. So we have log base b of b to the x and b raised to the log base b of x. And so we have the 6 here. So if I can get the 6 to go away, what I can do is I'm going to take the log of 6 on both sides, right? That's what's going to get rid of that 6. So let me show you. If I do log base 6 on both sides, then remember this is going to cancel out right here. And so what we're left with is log base 6 of x equals the y, or g of x equals log base 6 of x. So that is method 2. I always like to think about what can I do to make it cancel out. And so I take the log of base 6 on both sides. So that's example A. Let's do example B. Find the inverse of f of x equals log base 5 and then x plus 3 in parentheses. So we write this as y log base 5 of x plus 3. Then you switch the roles. So x equals log base 5 of y plus 3. And then, so if you want to rewrite it as an exponential, thinking about, how we did it previous lesson. So the base is 5, so 5. And then logs equal the exponent, so 5 to the x. And that equals the y plus 3, right? It's whatever's left over in here. Now to solve for y, you're going to subtract 3 from both sides. And so now you're left with g of x equals that 5x minus 3. So then what we're going to do is let's try this in method 2. So from here, let's write x equals log base 5 of the y plus 3. So we switch the roles of x and y. And so now we want to get rid of this log base 5. We want to write it in exponential form. So in order for this log of 5 to go away, look at it how it looks here. So one way to do that is to raise the whole thing to the, we're going to put the base of 5 and everything is going to be in the power as an exponent. So this is called exponentiating both sides with a base of 5. So everything here in these positions are now in the exponent position. So now that we've done that, we can go ahead and cancel the log base 5 over here. And so now we have 5 to the x equals, this drops down as y plus 3. Then we solve for y like we did previously. And so now we see that we get 5 to the x minus 3, and that is our new g of x. So you can use whatever method makes the most sense to you. I like to more think of like, what can I do to cancel it out? Instead of rewriting it as an exponential versus or an logarithm, but it's up to you, whatever makes sense to you. And so try these out. So whatever method you want to use, try these out and pause the video and see if you can get the answers for these. All right, so if you try this out, number 1, that's 10 to the x and then plus 2. So for what I did is I did method 2, so I exponentiated both sides with a base of 10, so I could cancel out that log. So now it's 10 to the x equals a y minus 2, and I solved for y, so I had to add 2 to both sides, and it's not in the exponent position. Number 2, that's just log of base 4 of x. Number 3, that's 4 to the x, and then this one, it's log base 5 of x and plus 3. There's no parentheses. Now, remember like what this means. So what this means is it's up 3. There is no parentheses. It should not be. If it is, then it changes the problem. So just be careful. We need parentheses if it was grouped together. In this case, it was added last, so therefore there are no parentheses.